Part A, I want the coordinates and nature of the stationary points of C. So the condition for stationary points is that dy by dx has to equal 0. So I state that first. Stationary points occur when dy by dx is equal to 0. So I find dy by dx, differentiating x cubed, that's 3x squared. Differentiating 6x squared goes to 12x, that's minus 12x, and differentiating 20 is 0. So now I solve this expression for dy dx equal to 0 to get the stationary points. So 3x squared minus 12x is equal to 0. Common factor, because it's two-term quadratic, x is common to both. So 3x is a common factor, x minus 4 equals 0. So 3x equals 0, or x minus 4 equals 0. So my two values of x are when x is equal to 0 and x is equal to 4. So those are the x values of the stationary points. Now then, so the coordinates then, I need to get the coordinates. So to find the corresponding values of y when x is 0, I go back to the formula they give me in the question. Y equals x cubed minus 6x squared plus 20. So for the first one, if x is 0, then y is 0 cubed is 0, minus 6 times 0 squared is 0, plus 20, so y is equal to 20. So there's the first coordinate, and then if x is equal to 4, y is 4 cubed minus 6 times 4 squared plus 20. 4 cubed is 64. Right, 4 squared is 16, 6 16s are 96, that's minus 96, plus 20. So adding that, 64 and 20 is 84. 84 minus 96 is minus 12. So there's the coordinates of the stationary point. Now I want the nature. So to determine the nature, I'm going to do the second derivative test. So I differentiate my dy by dx. So d2y by dx squared. So differentiating this dy dx. 3x squared goes to 6x. And 12x will go to 12. So there's my formula for d2y by dx squared. So now I test what the sign of this is when x is equal to 0. So if x is 0, d2y by dx squared is equal to 0 minus 12, which is negative. So if the second derivative is negative, then I've got a maximum. So 0, 20 is a maximum. And if I put x equal to 4 in, that's the other value of x where the stationary point is, then d2y by dx squared is 6 times 4 minus 12, which is 24 take away 12, which is 12. That's positive, so that means it's a minimum when x is 4. So the other point, 4 minus 12 is a minimum. So part B, sketch the graph indicating the stationary points. So sketch the graph. I've got 0 to 20 as a maximum, so the curve is doing that, and 4 minus 12, I've got a minimum. So the curve is a continuous curve, so this part of the curve will come down there, this moves to where the minimum point is, and then it goes back up. There's the x-axis and there's the y-axis. That's what the curve looks like. I've located both stationary points clearly on the graph. And the last part of the question is asking me, given that the equation, so I'm told that x cubed minus 6x squared plus 20 equals k, wants 3 distinct roots. Now then, don't get confused here with the quadratic condition. Okay, the discriminant, the b squared minus 4ac, is only to do with quadratic expressions. So I want three distinct roots. So I'm going to use the curve. Now if I draw my line across there, you see it only cuts the curve once. That would be one root. If I bring it down, just touching where the stationary point is, I'd have two roots. Coming below that, now this line would cut in three places, and I'd cut in three until I get down to the minimum point, where again it's coming back down to two. And then if I lower the line again, it'll only be cutting it once. So where I get three roots is between the two stationary points, between minus 12 and 20. So k needs to be between minus 12 and 20. And it has to be strictly greater than minus 12 and strictly less than 20, because if it actually equals those values, I'd only have two roots. So it has to be, say, strictly between those values for three roots.